All right, let's take a look at some triangles. And the first thing we want to do is remind ourselves of the triangle sum theorem. Okay, so we're going to take any triangle. It doesn't matter whether the triangle is obtuse, right triangle. It's going to have three angles. Let's just call these angle 1, 2, and 3. And we know that if we take angle 1 plus angle 2 plus angle 3, the measures of those, right, they all add up to 180 degrees for any triangle. This would be an obtuse triangle, but it's true for a right triangle. It's true for an acute triangle. The proof of that is actually pretty easy. So I can take two parallel lines. Okay, so these lines are parallel, we're going to claim. And I can pick any point I want on here and I can just draw a triangle. So, doesn't matter. Okay, so let's look at angle 1, angle 2, and angle 3, and then angle 4 and angle 5. Okay, we know that the angle addition postulate says that angle 4 plus angle 3 plus angle 5 has to be 180 degrees because they form a straight line. It's kind of like a linear triple, right? But we also know that angle 1 is congruent to angle 4, and we know that angle 2 is congruent to angle 5 because those are alternate interiors. And we know alternate interiors are congruent because the lines are in fact parallel. I drew them that way. But if angle 1 is congruent to angle 4, then I can substitute angle 1 in here, right? I mean, if this is 60 degrees, then this is 60 degrees. So if 1 and 4 are the same, then I can make a substitution for 1 put into 4, leave 3 alone, and then 2 and 5 have to be the same, so I can put 2 in for 5, and then look what I have here. Boom, the triangle sum theorem that says that no matter where I would have put that point, 1 and 4 are always the same, 2 and 5 are always the same, 3 plus 4 plus 5 have to be 180, so then 1 plus 2 plus 3 also has to be 180. I'm sure there are other proofs, but that's kind of a fun proof of the, again, the triangle sum, which we know relates to three angles of a triangle. Okay, there's another one. It's called the third angle. Third angle. And it says that if we have two triangles, and again, it doesn't really matter, if you know, let's say that this angle is a right angle and this angle is 40 degrees, and over here you have another triangle, and you know this is a right angle and this is 40 degrees. So you have two triangles that have the same angles. What do you know about their third angle? Well, hopefully it's obvious that then you know for sure that that angle and that angle are in fact the same. You don't even need to know these measurements. You just need to know that you have two different triangles and you know two of their angles are the same. Well, then you know the third angle has to be the same. In this case, we can show that they both, of course, have to be 50 degrees. Okay, so let's not overcomplicate the third angle theorem. It for sure guarantees that if we know two angles are the same, we know that the other angle is the same. We are not claiming that the triangles are congruent. We're just claiming that if you know two angles here and two angles here, then of course you actually know then the third angle of each, and the third angle of each has to be the same. Again, I'm not claiming the triangles are congruent. I'm claiming that the third angles of the triangle are congruent. Okay, now we're talking about congruent. Let's talk about congruent triangles. Okay, so let's look at a congruence statement and what that means. So if I said triangle A, B, C, is congruent to triangle MLJ, okay? What that means is that the order really does in fact matter. So if you just look at this congruent statement, you know exactly what side's congruent to what side and what angle is congruent to what angle. So this tells you, since it's ABC, MLJ, that means that angle A and angle M are in fact the same. That means B and L are the same, and angle C and angle J are the same. It also means that side length AB is matched up with side length ML. Side length BC and side length LJ are matched. Side length CA and JM are also the same. So we can kind of draw what this might look out. So again, it doesn't really matter how I draw them. Let's label these A, B, C. And so let's label another congruent triangle, right? And again, I'm going to draw it so the order is the easiest. A and M are matched. L and B are matched. And J and C are matched. Which means that this angle and this angle are the same, meaning the same measure. Angle B and angle L are the same. And it means that this angle is congruent to this angle. There are threes. That also means then side lengths. We can say that side length AB is matched up with side length ML. You see how the single side is matched between the single and the double, and the single and the double, right? The order matters. BC, we'll call that the double one, is then matched up with LJ. And this side is congruent to this side. And really, it's like, well, what does it mean to be congruent? Well, it turns out for two polygons, triangles, rectangles, parallelograms, whatever, figures, they're only congruent if all the corresponding sides and all the corresponding angles are congruent, right? So for these two triangles to be congruent, they both have to have a single side, a single angle, a double angle. I mean, they have to be the exact same triangle. Not close, not the same, just the same angles. They have to have the same angles and the same side. And so when you write a statement like this, you're matching them up. Now this guy looks like it's just a translation, right? I just took this triangle and I copied it and I just moved it over. But you know, you can do all those things. Remember, we did rigid transformations where we did a translation, a reflection, and a rotation, right? All of those lead to a congruent triangle. For instance, I'll do the reflection one. If I take a triangle up here, A, B, C, and I take this line and I reflect over to here, there, there, these two triangles are congruent. Now if I label this D, E, F, you know, what do I say if I say, let's say triangle BCA is congruent to what triangle over there, right? The letter matters, right? And you can just match this up. This angle and this angle are the same, right? B and E match. So then if I started with B, I have to start with E. This angle here matched up with this angle here. So I went BCA, so I have to go EDF. They all have to match. You can match up the corresponding angles and the corresponding sides, and each letter, the order matters, right? This side is congruent to that side. This side was this side. That side was this side, and you can look, right? D, E, and C, B are the same side. Okay, so if I give you one, you can write the other. And again, all three of these, translations or moves, reflections, or even rotations, they still keep the congruent triangle. And so, you know, if I could give you two sets of congruent triangles, you can tell me how I got from one to the other, right? From here to here is just basically it looks like I moved it over to the right and maybe down a little. This one I reflected over that line, and then certainly I could rotate a triangle. And again, the only way triangles are congruent is if they're exactly congruent. The biggest thing is you want to match them up perfectly so they are in fact, you know, the exact same triangle. So if I drew a triangle like this, and this was 30 degrees, 100 degrees, and 50 degrees, and this was 6 inches. I'm making this up. So these numbers, if you actually check them out, might not work, but I'm just kind of, oh no, I can't do that because this is going to screw things up. This side, well, it'd have to be the shortest side. It's okay. 8 inches, and then we'll say like 11 inches. That's probably close, but that actual triangle would be formed. It might not be that exact relationship, but it'd be close to that, where if this was A and this was B and this was C and we were looking for another congruent triangle, maybe the other one looks, you know, like this. If they're actually going to be congruent, like this 11, since this is the longest side, would have to be there. This would be 8 inches. This would be 6 inches. It would have to be the exact same triangle, right? But if you think about how this was oriented, this B and this angle have to be the same. So this is like some B prime and some reflection. The 11 and the 8 are with that A, so this would have had to been A prime. They'd have to be matched up, and that would have to be C prime, right? They have to be the exact same triangle, and if you wanted to compare, you can just match them up. Now, I ordered them this way, so in this case, triangle ABC would be congruent to triangle A prime, B prime, C prime, but lots of times they're not going to use primes in this unit. They're going to just make these new letters, and they're going to say that's M, P, Q, and you have to decide, okay, look what M is the point between the 11 and the 8. Well, the 11 and the 8 are A, so M gets matched up with A. So instead of saying this, it would have been M, P, Q. The whole goal is you have to match them up in the correct order. And again, that's saying that angle M and A are the same. Angle B and P are the same. Angle C and Q are the same. Side length AB and side length MP are the same. Everything is matched up according to all those things. Okay, maybe the last thing you want to do is you might want to like write small proofs of certain things. And so if I give you some things, you basically need to get to the point where you know that everything is the same. So there might be, you know, one like this. It's like that's the same as that. That's the same as this. This is the same as this. And you know, that angle and that angle are the same. And you're like, okay, is that enough? And you'd have to talk through, it's like, well, you actually know that these are the same because those are vertical angles. But if those two are the same, and this triangle's got a single and a double, and this triangle's got a single and a double, well, the third angle theorem says, well, those have to be the same. But if those are the same, then the triangles are actually then the same, meaning both triangles have a single, double, triple side, and it works out perfect. You see it, like the single angle is right in between the triple and the single. The double angle is right there, and the triple angle is between the double and the triple side. So these two triangles are for sure congruent. So since they're congruent, we can write a congruent statement. So let's say A, B, C, and D, and E. Okay, now let's write this. And it doesn't matter, you can start with any three you want. You could have said CAB or whatever. Let's say ABC. My brain just did that on accident. Okay, so if I said ABC, then I have to do the same thing over here. So what goes with A? See how A is the single? So I have to start over here with E, and then where do I go? Well, I'm at A, and I go down the triple side. So at E, I gotta go down the triple side, so I gotta go D and then back to the center. So that matters, right? If I said ABC, I can't say ECD. I have to go EDC. Now, I wouldn't have had to gone ABC. I could have said this one was, you know, BCA. Well, BCA is starting with a triple, so then I would have started with D over here, and then I went to the center, so I'm going to go to the center, CE, right? It's matching them up. In both cases, B and D are matched, right? And so on. So you have to be really just careful with the letters, and then you'd write some proof to say, well, in this case, these vertical angles are the same, those angles were the same based on the third angle theorem, and then if you have all the angles and all the sides are congruent, then you have congruent triangles, then you can go ahead and write the congruent statement, okay? So we got congruent statements, kind of working on looking at whether things are congruent or not, or why. And again, in all these scenarios, the triangles that are congruent because you've taken a triangle and you've either translated it, reflected it, or rotated it around, but it's the exact same triangle, meaning it has the exact same sides. So 3 big things are congruent statements, using the third angle theorem, and the triangle sum theorem. And hopefully this video kind of helps you get started on this next unit.